Okay, apa itu kapasitor? Kapasitor a device that berbanding dengan sebelum ini kita buat wire itu panggil konduktor. Konduktor charge boleh flow kan. Ini pula a device that ada kaitan juga dengan charge, tapi dia menyimpan. Stores charge. Menyimpan charge. Okay, so paling senang kita guna two parallel metal plate with insulator in between. Kita dua metal dan satu saja insulator in between. Insulator itu in capacitance we always call it dielectric rather than insulator. Okay, dan simbolnya pun memang menunjukkan dua plate, tengah-tengahnya tak tersambung. Kalau sambung pun dengan insulator ataupun dielectric. Okay. Macam mana lah dua plate saja boleh menyimpan charge? Okay, so let's see what will happen when it is connected to a battery ataupun cell. So connect here and connect here. Okay, keep in mind battery, this is a positive terminal and this is a negative terminal. So electron will move from negative terminal to plate A ke B? B. B.
Bukan A ke?
Negatif ke sini kan?
Ya, ke A.
Okay.
Oh, ke
B.
B.
Negatif kan? Elektron bukan charge bukan current lah. So to plate B. Ya, elektron keluar di sini masuk sini. Menjadikan so B becomes, tapi ingatlah charge itu bukannya boleh melompat sebab di tengah-tengah ada insulator atau dielectric. Okay. So B becomes positive, negative?
Negatif.
Okay.
Negatif.
Negatively charged. So bila dia negatif, what will happen to plate A?
Positif.
Kenapa?
So kurang charge, kurang elektron.
Kenapa kurang elektron?
So sudah
Tolak oleh
Itu dah mana?
Sudah.
Dia akan menolak. Kan? Bukan sebab ini. Kan?
Yang
And this is negatively charged, it will induce a positive charge on this side by pushing the electron sini pula, kan? Nampak elektron tadi masuk sini, dia bukan melompat lah, tetapi dia induce. So A pula become positively charged. Positively charged. Sorry. Electron will move from mana? A kan to positive terminal. Sorry ya, kan yang ini tadi elektron ke sini, this one become negative. So we induce a positive charge here because we push the electron from A back to the battery. Okay. So menjadikan A positively charged. Okay, but keep in mind, ada tak charge yang melompat dari A ke B? A ke B, A ke B. Tiada. No electron actually move from A to B. Since we have an insulator, or we can actually just leave it as a vacuum pun boleh. Vacuum in between. Okay, which one will have more charge, A ke B?
More charge.
Sama kan? Alright, magnitude of charge of A equals to magnitude of B. So bila dia ada positive negative, it will create apa?
charge.
It will create current no. Bila dia ada charge, bila ada different
V.
charge, actually V. Actually dia akan create a electric field. So electric field ada electric field strength and also potential. Tapi in most cases kita tengok potential lagi penting. Bukan lagi penting lah, just that we get used to using it. So a potential difference is created between A and B. Okay. Katakan so ada potential difference dalam kapasitor itu. Okay. Even though kamu tengok total elektronnya sama kan, just that one side become negative, one side become positive. Okay, so as time goes by, semakin negatif kan? Semakin banyak elektron pergi ke B, semakin banyak elektron A pergi ke balik ke itu. So it will increase. So this potential difference will increase as more charge flow in.
Small charge.
As more charge flow in. So do you think it will keep on happening? Sampai infinity kah charge ni? Think about it.
Dia nak
Seimbang dengan apa?
V.
V of apa?
Potential.
Potential of what?
Energy.
Energy of what? How are we pushing the electron? We using a cell. Yeah, we using a cell. We using a battery, a source.
Bagusnya.
Okay. A source of electric always has a constant V. Kan macam bateri tulisan 1.5 volt kan. Sama dengan that. Yeah, always has a. So rasa-rasanya because the battery need to push di sini sudah negatif sekarang. So does it become easier for you to push the electron or does it become harder?
Easily.
Harder sebab dia sudah negatif.
Oh iya.
Kan bila sudah ada elektron kamu push lagi elektron dia akan harder. So di atas ada V, di bawah pun ada V. So that means it will actually just flow until V lah. Ya. So V tapi V apa? V between AB
Dia seimbang.
equals to V of your cell.
Because
V of your cell we
cell.
sometimes we call EMF of cell. PM we call it apa? DGE. But it's still the work, yeah, the work between of your
Electron motion.
battery. Okay, but so what? Ingat kita, what is a capacitor? What do you want capacitor? Untuk store charge. So sekarang charge ini bukan di sini kah? Di dalam sudah?
Di dalam sih.
Di dalam, tapi bukankah dia akan hilang?
Iya. Dia store sudah ada.
Dia store, tapi penting kalau kamu tak mau dia hilang, kamu disconnect. Kamu disconnect itu battery. So dia punya charge begini. Pada positif. Adakah dia boleh hilang secara sendiri?
Tidak.
Tidak lah. So charge stay on the capacitor. Nampakkan bukan dia semakin banyak elektron ke kurang elektron, tetapi satu belahnya kurang elektron, satu belahnya banyak elektron dan dia tak boleh jump kan, sebab dengan unless kamu dischargekan dia. Nanti kita tengok macam mana kita discharge ni. Okay, so that's how we build a capacitor. Okay, using nothing but just 2 plate lah.
Unless kita discharge capacitor.
Okay, next so kita mau ukur dia punya since capacitor itu untuk charge, then kita mau ukur dia punya apa?
Maksimum untuk simpan.
Kebolehannya untuk simpan charge lah kan. Okay, but you can see how much charge also depends on V. Kan? If you use a bigger battery, then you will be able to push more charge inside. Okay, so capacitance C. Simbolnya C, ratio of charge stored in capacitor. Sebab dia bergantung kepada V. Semakin tinggi V, semakin tingginya. So kita bahagi to the potential difference. Potential difference applied across the capacitor. Okay, so in other words, C equals to Q over V.
Apa semakin tinggi V-nya
Makin banyak charge-nya.
makin banyak charge dia simpan.
Iya. Okay. Tapi makin tinggi C-nya,
Makin rendah
V-nya.
makin tinggi C-nya,
Mesti tinggi.
maksudnya lagi tinggi Q-nya untuk V yang sama. Ini semua kapasitor dengan big kapasitor. Kan? Untuk satu kapasitor, for a certain capacitor, the higher the V, the higher the Q. kan?
Oh,
But
yeah.
if you're comparing different capacitance, then the higher the C, the more charge you can store for a certain V.
So ada ke dia punya Q constant tu?
Ada.
Oh,
Ha. Nanti kamu tengok series ke parallel. Nah, kan? Kamu biasa sudah kan, when you have three things like that, you can never make a simple conclusion, masih apa yang constant. Kan? What are you comparing? Okay, question. Where is the charge? You have positive Q on this side and negative Q on this side, ataupun the other side, ataupun apa. So charge stored, is it 0 or 2Q? Nope,
V.
it's Q. Bukan 0, bukan 2Q. Because actually dia punya konsep ialah how much charge, kita simpan charge berapa kan? Kita simpan untuk apa? Nanti untuk guna kan? Okay. So the thing is, if you connect it later to a resistor, how much charge will flow? 0 ke 2Q ke Q? Q, because exactly 1Q will flow from here to here and then dia habis. Faham kan? So when we write plus Q, negative Q, the charge stored is actually Q. Okay, so unit based on formula, Q is a coulomb. C lagi, C lagi, unit kan? Coulomb, V juga, CV negative 1. Okay, but we give it a special name, F, Farad. Siapa tu si Farad? Faraday lah.
Oh, sama orang.
Dia lah tu. Tapi kenapa Farad? Why not Faraday?
Ada Farah.
Farah. Higher C can store more charge. Itu dia.
Less.
Itu dia.
Q per V. How do we define Q per V?
Constant.
More charge
At certain
per unit
V.
potential difference. In fact, C can be defined as charge stored per unit potential difference. Okay, ataupun ratio bla 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 bagi bla bla. Okay, so we're going to relate this with electric field, and then we can see rasanya lah. But you can see sudah rasanya kalau C besar, plate-nya besar ke kecil? Besar lah kan?
Besar.
So it has to do with area of plate. Let's say put at A. What F?
D.
D. Distance between the plate. Very good. Separation. Okay. What type of electric field will we get for a parallel plate? We get a
Parallel.
uniform electric field. E is constant. When E is constant for a parallel electric field, what is the formula that we always use?
E.
E equals to
D per B.
E equals to V per
V.
D.
P per D.
Okay, V refer to potential difference sudah, and not potential. The original formula is E equals to negative dV dR, where V is the potential. Okay, but here we always deal with potential difference anyway, so directly V per D lah. What do we want? How about charge? We need charge kan?
Yeah.
So a positive Q on this side, negative Q on this side, and a potential difference of V across. So we want to relate V and C kan? Kita mau C kan? We want C. C is Q over V. V is related to E. Q will also affect E using
E equals to F per Q per F.
how does the charge affect the electric
F
field?
over Q.
Using Gauss law.
Oh, yeah, flux.
Okay. So Gauss law, you need to choose a closed surface. So you look at the field, closed surface apa yang sesuai. So that it's always perpendicular to your electric field. Then it has a certain amount of charge inside. So let's suppose it's Q. Okay. Kenapa kita tak ambil semua? then the charge becomes 0 kan?
Yeah.
So just that side. So epsilon, the Gauss law not originally was what? Epsilon naught with a flux and a sigma q, right? Okay, but now since we are going to use an insulator, so it's not epsilon naught, it is epsilon, where epsilon equals to epsilon r multiplied with epsilon naught, where epsilon r is called the in electric. Electric ni panggil apa?
Medium.
Yalah, epsilon apa panggil apa? What's the name?
Permittivity.
Permittivity of free space. Epsilon r is relative permittivity, and epsilon is permittivity. In electric, here we're going to use another name, but it's the same value. Okay, so what should we do? Epsilon, what is flux? E multiplied with A, because we choose a surface always perpendicular and E is always constant at the surface, and the charge is positive Q. What are we trying to do? Kita bukan cari E. We are trying to relate V with a Q and a C, capacitance, kan?
E tukar.
So E tukar kepada V per D, good. Q biarkan kan? Q biarkan epsilon. What we want? We want C. C which is Q per V. Oh, maksudnya susun lah. Nanti you get Q per V. Alright. So Q per V, what do we get? Ada apa?
Epsilon.
Ada epsilon,
A
ada
per D.
A, ada D. That is your C. So epsilon A per D ataupun epsilon A, epsilon naught A per D. Okay. Then look at it. Does it make sense? C depends on A, and you can see the higher the A, the higher the C. Logic lah kan, lebih besar lebih banyak charge lah, dia bersimpan. Okay. It depends on D. Lebih dekat lebih jauh, lebih bagus.
Lebih dekat.
Lebih dekat lah, make sense lah kan. Lebih dekat V nya lebih tinggi. Kan E equals to V per D kan. Kalau D kecil, V tinggi.
Semakin banyak yang
Right.
induce-nya tuh.
Lebih kurang lah. But anyway, doesn't logic kan, kalau jauh susah lah kan dia induce ya. And then of course the epsilon R, which is the depends on the type of insulator ataupun dielectric insulator ataupun dielectric. So permittivity of free space 8.5 times 10 power negative 12. Do you remember what was the unit? Even? It's actually farad meter negative 1. And you can actually prove it from this formula. Kan? Yang topik sebelum tiba-tiba ada F. Mana F itu? I think it's quite easy kan? Because this is a farad. This is just a meter square. This is a meter. This is dimensionless. Okay. So epsilon R, we used to call it relative permittivity, but here we call it dielectric constant. Dan dia tiada unit lah because this is a ratio. Okay. So in vacuum, so it's just epsilon naught A times a D. For air, not air, air.
Kenapa epsilon not charge?
Because vacuum kan, so tak perlu lah epsilon A.
Medium.
Okay, but normally takkan nak kita purposely jadikan vacuum, kita biarkan dia air pun boleh. Tapi in air it is almost equals to 1 anyway. Okay, so you can use epsilon naught A. Okay lah.
Oh, so
Sama juga.
Because almost equals to 1. Nanti kita tengok how does the insulator actually increase the charge.
jadi sebenarnya vacuum sama air sama saja lah.
Yes. Alright, do the calculation. The first one you get
Yeah.
1.77 10 power negative 9 farad. 4.07 10 negative 9 farad. So that means 1 farad is actually very very big.
Very big.
Very big. Normally kamu akan guna microfarad dan sebagainya.
Biasa.
Okay, yang kedua you try, it should be 6.4. Dan yang ketiga it should be 2.86. Iya, kamu banding the formula is C epsilon naught epsilon R A over D. Okay, so it has the same capacitor. The only thing you change is you fill in the plastic. So epsilon naught itself is a constant. A tak berubah, D tak berubah. So the only thing we have is C proportional to epsilon R. So if in air, epsilon R equals to 1. So itu je. So you C2 per C1. C2 per C1 epsilon R over 1. Okay. Supaya cepat. Ya, kalau dia cakap air, kamu guna 1. Alright, so you end up with C2 C1 epsilon R to 1 actually. So epsilon R per 1 32 per F5. Micro tak apa kan, dia potong juga kan. Yang kedua, you must know what is constant and what is not constant. A capacitor with air in between the plate is charged to 12 volt. Battery is removed and the space in between is filled with an insulator. Potential difference drop to 4.2. Nombor 3, V yang berubah. So what formula?
C equals to Q per V.
Yes, okay. C equals to Q per V and C equals to epsilon naught epsilon R A per D. So battery is removed. Ini actually very penting itu. Because when battery is removed, maksudnya dia disconnected. So apa yang akan constant? Not C. Not C.
Q.
Yes, the charge cannot go anywhere. So Q is the one that is constant. Okay, and then kamu tak tukar tu kapasitor kan, you just change your R. So that means epsilon naught A and D is also not affected. So C proportional 1 per V, C proportional to epsilon R. So combine dia. So epsilon R 1 over V. Okay, then it becomes simple calculation. Okay, but it's bukan mathematics actually. Is you need to understand the physics what is happening. Dia disconnected, so Q nya tak boleh alih keluar, so Q is constant. Okay, but the V is affected by C because the C itself is changed. Okay, so kita epsilon naught itself is a constant. Memang nilai constant kan? A and D is the dimension of your capacitor. Your capacitor kan? Dia tidak cakap ada apa-apa kan, dia kata dia hanya letak sesuatu di dalam.
Kapasitor yang sama.
Unless they say you increase the distance ke, decrease the distance ke, kan? So it's the same capacitor. So something in between. Okay, so now we look at kenapa insulator itu. The insulator increases the capacitance kan? Ikut formulanya epsilon R. Increase the capacitance kan, so membenarkan dia menyimpan lebih banyak charge. Alright. Maka kalau kamu buka itu kapasitor yang kamu ada kan, kamu akan nampak memang ada insulator. Kapasitor kamu pernah nampak di yang sebenar? Sama dia benda besar begini. Kadang-kadang lihat, tapi dia besar lah.
Iya.
Dia besar, dia perlu besar.
Dekat TV saya ada.
Dia perlu besar sebab dia perlu charge.
Yang dekat sini ada sih.
Ada di kipas.
Sini. Dekat fender floor ni.
Fender floor, I'm not sure. Mana kipas pun. Dan kenapa dia bukan gak ada sepatut begini? Yalah dia diguling-gulingkan di sini lah bang kan. Dia gulingkan supaya dia mengambil lebih sedikit tempat. Okay, but basically the construction is like this. Okay, so what does the insulator actually do? Because without the insulator, it's just a negative positive on the plate. Bila dia sudah di charge. Okay. So when there is a charge, that means there is a electric field generated between the plate. Kan? Kita lukis di atas, the electric field E. Right to left, left to right,
Left to right.
left to right. Kenapa? Kan lah, positive to negative kan. E shows the direction of force on a positive charge placed at that point. Okay, so what will happen to the insulator in between? It is not a conductor, it's an insulator. Bila dia letak dalam electric field. Okay, in fact, it's something like your chemistry. Walaupun dia sendiri adalah neutral, but because there is a electric field, dia akan ter-induce supaya satu belahnya negatif, satu belahnya positif. Okay, or we say molecules are polarized. Ni macam induce. Induce apa?
Teraruh.
No, I mean chemistry apa? Induce, temporary, induce. Temporary induce, permanent induce. Okay, so sekarang if you look inside itself, dia adalah positive, negative, which means that inside there is another, dia akan create satu electric field yang terbalik. The molecule itself, sebab dia positive, negative kan. Okay, so what we have is a reverse electric field. Is set up. Okay, mikir logically ya. Dia ada E. E dia menyebabkan molekul-molekul di dalam polarize menghasilkan E yang terbalik. Kan? So apabila begini, then the resultant electric field increase ataupun decrease.
Sama. Zero.
Resultant. No, it will not be the same because it is an insulator and not a conductor. If it's a conductor, then it will ngam cancel. It will just polarize. Sebab dia polarize kan. Of course, E prime is less than E lah, kan.
Yeah.
Tetapi bila kamu tambahkan,
Kurang.
then it will decrease. Okay, so the electric field decrease. But in capacitance, we normally don't use E, we use V. Kan? So what will happen to the V when E decreases? Guna formula apa?
V per D.
Yes. Okay. So when your E decreases, because there's an inverse electric field, so V pun decrease. Alright. So potential difference across the capacitor decreases. Decreases, yes. Now at this point, there's two things that can happen. If you tengok balik soalan tadi, this question lah, if it's removed, then the V just decrease lah. Kan? V ni akan decrease kepada 4.2 for example. Okay, and nothing else will happen. Okay, but you want to explain apa sebenarnya? What do you want to explain? We want to explain why the epsilon R end up increasing your C. C, which is charge per V. So kenapa dia increase? Kenapa dia boleh menyimpan lebih charge? Of course, if you say V decrease, then C increase boleh juga, but there is just mathematics saja. You say Q per V decrease, so C increase kan? But does it actually mean that it can store more charge? Okay, so it depends. If you are still connected to the battery after you put in the insulator, so sekarang V nya sudah decrease, Ingat dia akan charge akan flow until
Until V.
dia sama dengan bateri. So imagine dia sudah sama dengan bateri, lepas tu kamu tambah lagi insulator, so dia V decrease, maksudnya sekarang V bateri kamu masih lagi besar daripada V. Okay, so it's still connected to the battery, then what will happen is actually more charge will flow. Will flow in until dia punya V increase balik to equal EMF. Kan? So maksudnya C equals to Q per V. So for the same V, for the same EMF battery ataupun for the same potential across the capacitor, we will get more charge lah. Ya. Sebab bila ada insulator, E nya akan berkurang, so akan more charge akan flow in sehingga dia dapat balik V yang tadi. So Q increase, so C increase lah.
Tapi V constant.
V as in what V? Again, maybe you put in value easier. Let's say this was 1.5 V, kan? So tanpa insulator dia akan charge to 1.5 V juga, kan? Then when you put in the insulator, this one will drop to let's say 0.5. Kan? So when this is 0.5, this is 1.5, then more charge will flow until this one become back 1.5. So dia lebih charge berbanding dengan tanpa insulator tadi. Okay. But what if we disconnect from the battery? Does it still apply? Ya, ini macam tadi lah. Okay. Disconnected from the battery, kamu sudah charge and then barulah kamu masuk insulatornya. Do we still say that the capacitance increase?
No.
Because the E will become actually, we can also use Coulomb's law kan? When you have insulator, the E become 1 over epsilon R E. Remember Coulomb's law? QQ 4 pi epsilon naught epsilon R square kan? So, kalau insulator E nya akan decrease, so V nya pun decrease by the same factor, right? Because E equals to V over T. So bermaksud Q cannot flow anywhere, tetapi V decreases, so C increases. Okay, so this is to explain why the dielectric work. Okay, in both cases lah, we can see the C increases lah. We can justify kenapa C dia increase. Because we look at Coulomb's law kan, yalah, doesn't matter kan whether E dia ada satu Q atau tiada Q. The important thing is you just want to see how does epsilon R affect your F, which means it will affect your E, which means it will affect your V. Yeah. Alright, so sama dengan resistor, we can connect it in parallel and we can connect it in series capacitor. Okay, but sama juga dengan electric, the important thing is not the formula, is you understand in series what is the same and what is not the same. Okay, so can you imagine dia punya charge akan jadi macam mana, dia punya flow. If we put it in series, bila kita mau charge kan dia, what will happen? Electron bergerak ke sini and then it will jump across kan? Tidak kan? Dia akan induce pula elektron gerak sini ke sini. And then ini pula induce ini ke sini. So what is the same? What must be the same for each capacitor? Q, V or C? No, just by looking at how it flow. Q. Because the amount of charge that come here is negative Q, it will induce a positive Q. So here be negative Q and here be positive Q and negative Q and positive Q. Just by the way how it charges. Same like resistor. Kalau resistor, what is the same? I lah.
Yeah.
Because the rate of flow must go back to the battery. Bukan go back, the rate must be the same. Okay? So not by formula anything. In series we know the charge is the same. is the same for each capacitor. Whereas the V, as usual, samalah dengan elektrik kan, ataupun current. Sebab V actually refer to work done kan? Work done. EMF refer to energy supplied by the battery. So obviously, energy supplied by your battery, you do work here, so this will be work 1, work 2, work 3. Not work lah, V1, V2, V3. So total V is sum of individual V.
Individual B.
Yeah. So like capacitance, like resistor, we want to change this to a single capacitor total C. Okay, but the actual word is not total lah. The actual word is equivalent capacitor. Maksudnya kalau 3 kapasitor itu ganti dengan satu kapasitor lain, apakah capacitance kapasitor tersebut yang mempunyai kesan yang sama? Apakah capacitance pada kapasitor yang sama dengan 3 kapasitor tersebut digabung dengan cara begini? Because when you say total kan, total selalu kamu ingat mau tambah kan?
Yes.
Dia mesti tambah. Macam resistor pun kan, sometimes bukan tambah kan, kamu guna 1 per A, 1 per A. Okay, first thing we need to be clear is how about the charge? How many Qs are there? Charge on each capacitor, is it 2Q or 0.0?
Q.
Q. Total charge, is it Q? 3Q? 0?
Q.
Q. Why?
Sama kan? Q.
Bukan sama. The thing is how much charge can you get back? Kalau kamu remove dia punya battery, kemudian kamu sambung balik, how much charge can you get back? Q juga.
Seperti yang hilang.
Q juga. Q juga sebab dia kan flow balik sini kan. Kecuali nanti kamu splitkan dia, nanti kamu sini dapat Q, sini dapat Q, sini dapat Q. Actually there is a way later. Okay, but for now we assume the total charge is Q. Okay. And then potential juga. Why is it selalu begini ialah potential? Di mana lagi kita tengok potential? Gravity kan? Mana gravity dia bergantung pada tinggi kan, perbezaan tinggi. So something like this lah. H1, H2, H3. Dan kalau gravity pun kita tambahkan, so samalah dengan elektrik. Okay, so V is V1 plus V2 plus V3. But if you understand what is V, what was V? Work done to bring the charge from point A to point B kan? It's work done kan? Work done, total work done. Ataupun total energy supplied. Sudah tentu perlu ditambah lah kan? If it is in series. Kalau parallel lain cerita. Okay, so now we want to find the formula. So we just apply C equals to Q per V. So what is V besar? What's the total V? Total V ataupun equivalent V kah boleh kan? So V equals to Q per C, where C is the total C kan? Ini total, ini total, ini total. How about V1? Do we need to write Q1 C1, Q2 C2, Q2 C3? And why?
Because Q kan sama.
Okay, Q sama. So that means Q, but C1, C2, C3. Kan? C depends on the dimension of the capacitor kan? A-nya, D-nya dan insulatornya. Ui. So ingat lah when we do C, this is the total, this is the total, and this is the total lah if we use the total. Oh, so cut away the Q. So what formula do you get? So 1 over C, 1 over C1 plus 1 over C2 plus 1 over C3.
Ini kenapa dia macam tu?
Nampak? Coba kalau kamu potong dia punya Q, Q kan? So which means for capacitor in series, sebenarnya bila kamu tambah begini dia akan lebih besar ke lebih kecil? Lebih kecil. Logik dia lebih kecil. Actually yes, because you can see the V for each capacitor actually mengecil sebab dia kena share dengan dua kapasitor yang lain. Kan? So maksudnya kalau dia satu kapasitor, kamu tambah lagi satu kapasitor, in fact you get less charge. Kan? Because the V itself has to be shared. Okay, if more than 3, tak ada masalah lah, tambah lagi lah kan. Okay, C is actually less than individual capacitance because you actually have to share your V. Okay, and sometimes dia bukan mau kamu mengira senang je guna calculator. They just want you to compare. Same dimension. Sometimes they say same dimension, so same A, same D lah. Okay, compare Q, C and V. Q, C and V. Depends lah, yang mana senang compare dulu. Which means compare C1, C2, compare V1, V2, compare Q1, Q2. Lebih besar sama dengan ataupun lebih kecil.
Q.
Yang mana kita confirm dulu.
Q.
Q 1 equals to Q. Very good, because it is in series. V, can we see? We know that V1 plus V2 equals to V, but we do not know which one is bigger or whether it is equal. Kan? We know V1 plus V2 equals to V, but we do not know what's the relationship between V1 and V2. Then look at C first lah. How about C?
C1
is bigger than
C2.
Why?
Sebab
Ada
insulator.
Ada insulator bukan lebih besar ke C?
C ya sir, lebih besar sir. Lebih besar C.
Situ lebih besar.
besar.
V sir kan yang
V tak tahu. V tak tahu. Hati-hati. V we don't know.
So
Eh?
total makan.
Then kita tengok apa lagi yang kita tahu. Okay. So now in this case we know Q and C. So we know V. Because C equals to Q over V. Okay, hati-hati ya. So in this case Q is constant. So a higher C will actually have a lower V. Which means that V2,
V1 high, V2 kecil.
Less.
V2 is bigger.
which means V1 is bigger.
ya,
Okay.
V1
V1 is bigger. Okay, so that's in series. How about in parallel? Parallel same dengan yang parallel untuk resistor. Konsep apa yang paling penting? Parallel. When you have a battery, when you connect one resistor, so certain I keluar kan. You connect another resistor, apa yang sama? Apa yang sama? It's not the charge, it's not the I, it's not the Q, it's not the R, it is the V. Because V itself refer to work done, but in this case it will be the energy supplied lah ataupun apalah, energy supplied to per unit charge. Per unit charge. It is the definition of work done kan. Work done bla 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 per unit charge. Okay. So sebenarnya when you sambung more like this in parallel, dia hanya lebih banyak charge yang keluar, tapi setiap charge yang keluar masih mempunyai tenaga yang sama, mempunyai V yang sama. So always in parallel, what we have is the V is the same. any type of circuit, as long as parallel, what we get is the V is the same. Because charge flow from higher V to lower V kan. Okay, how about the Q? So this way positive, 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 negative, negative, negative. Does the Q need to be the same? No. So the Q1, Q2, Q3
So do not share.
do not share. Sebab dia bukan flow dari satu tempat ke satu kapasitor yang lain kan. So in fact, so if it's not the same, dan juga, so how much is the total charge?
Lagi 3.
Q1, Q2, Q3
Q.
plus together. Kenapa? Sebab kalau kamu disconnect, kamu flow kan, ini boleh keluar, ini boleh keluar. Charge ini keluar kan. Maksudnya sum lah. Kan? Sum. So total Q is sum of individual Q. Again, this one you can just look at. It's not a mathematical formula, just look at the situation. Like that sudah. Okay, so sekali lagi, we want to compare with a single C and the battery. What is the equivalent capacitor? Okay, so V is the same. Meanwhile, charge on each capacitor, does it depend on other capacitor? No, independent on other capacitor. Okay, so kamu tambah lagi banyak secara parallel, you get more charge lah on each capacitor. Nah, you get the same charge on each capacitor. This at the total charge will increase. It is exactly the same with current. Current, when you do like this, there's a I. When you tambah like this, there's another I. Just that in this part, kalau kamu combine, kamu dapat I1 plus I2 lah, which increase lah. But actually, each part is independent from the other loop because the V is the same. Okay, so what will happen for calculation? We start dari mana? Tadi kita start dengan V equals to V1 plus V2 plus V3. Here we start with I, no I lah kan?
Q.
Q. So Q equals to Q1 plus Q2 plus Q3. Then the Q we change it to CV. So yang total ini total C, total V lah. How about Q1?
C1V, C2V.
C1V, because there's only one V, tak perlu V1. So C2V, C3V. Simple. So C equals to C1 plus C2 plus C3. Okay. And again, it makes sense. Sebab we put one more in parallel, then dia simpan dia punya charge sendiri lah. So sudah tentu capacitance kamu pun tambah saja lah. Kan sebab masing-masing kapasitor menyimpan charge kan. So kamu tambah, so capacitance semua tambah saja. Right? So if more than 3, no problem, we just plus it. So C will be, as in total C more lah kan. More than individual capacitors. Tapi charge-nya kan, it's like macam tak adil ni. Kenapa sini? Ya, kenapa sini sama? Positive Q, negative Q, and positive Q, negative Q, positive Q, negative Q. Kita sambung. Where's the total charge? For this one.
What is
Total charge
Q kan?
yeah.
This one?
Q. 2Q.
2Q. 2Q. Because of the way it can flow out. You can see you flow out from here and you flow from here.
Yeah.
QQ. So charge-nya 2Q. Ya ini There's only Q, there's only Q. Sebab yang ini, di sini Q, di sini Q, di sini Q. Saya atas di bawah pun Q saja. Di sini 2 Q can actually flow out. Kan? Unless you take this one and then you can rearrange to this one. Actually boleh, soalannya ada yang begitu. So be careful lah. The total charge depends on how the charge flow out later when you want to check it. Okay, so sama juga. Sometimes they just test you, especially in objective. Sangat senang, tapi sangat senang juga tersilap. So be very careful. Same thing, compare Q, C and V. Tapi it depends on which one first lah. You see which one you know first.
Q first.
No, we don't know the Q.
V.
We know the V.
Parallel.
We know the V because it is parallel.
V1.
Q. We know Q1 plus Q2 equals to Q, but doesn't help.
C.
C1, C2,
C1,
C2 lebih besar because it is insulator. Which means the Q
sebab C itu insulator.
ada insulator. The other things are the same lah. Suppose ada A, D sama.
So Q1 sama ada dengan C.
Ikutlah tu, ikut
Sama?
Q-nya tu
Q1
sama
lebih
juga. Yang
kecil
Q1
dari
lebih
Q2.
kecil dari Q2.
Yes. C equals to Q per V. Higher C, higher Q lah. Ngam lah. This one logic lah. Kan, he has a higher capacitance, so dia dapat store lebih banyak charge because it is experiencing the same. Kan? Sudah tentu totalnya pun C1 plus C2. Of course, because it's a calculation, so sometimes terlalu mudah tak boleh juga. So you try to make things more complicated for you. So let's say this is 2 microfarads, 1 microfarads, this is 4 microfarads and 5 microfarads. So series parallel, the parallel is in series with the other two. So what should we think first?
Series
Inilah
bahagi 2.
4 and 5. Do we plus it together ataupun kita guna 1 plus C, 1 plus C?
Plus
Plus kan? Plus. Which means that is actually 9.
9 micro.
Then you have 3 of them in series. So 1 over 2, 1 over 1, 1 over 9, 1 over C. How about the micro? If you're supposed to put the micro here, but it's going to make your calculation very difficult. Kan?
Jadi enggak perlu sih.
Tak perlu, but remember final answer put back the micro.
Oh. Enggak perlu tekan di calculator micro.
And it will make your life very difficult. Kan? Because you need to work on over 2, 1 over 1 over 9. Dan jangan lupa nanti you can write like this ataupun sometimes the book just write like this. Faham tak maksudnya? Sama. Dia 1 over itu kan. But sometimes you forget.
Dia 0.6
to 1 microfarad. Oh, actually kalau kita cakap tak letak dah boleh. Letak. Tapi jangan tekan di calculator.
Yeah.
Kalau enggak letak pun tak apa sih.
I'm not sure lah, bisa tahu.
Tak.
Okay, so this one, find total Q and Q on each capacitance. So you apply everything that you know. So there will be total Q.
Di situ dulu sir.
is 54 microcoulomb. The others I just put the value here. Nanti mau check lah. So this is 30. This is 4 microcoulomb. This is a 4. This is a 20. This is a 24.
54 microcoulomb.
This is a 24. Okay.
I will do one.
In fact, lepas kamu dapat jumlahnya kan, Yang bawah tu senang because we know this is 10B.
Ya.
Yang atas itu maybe we do like this lah. We just concentrate on A to B.
Ya, akan lagi sampai 10.
And dia ialah 10B. So you can just take the total capacitance for this strip. Tadi sudah, yang sebelum tambah 3 itu berapa? Sebelum tambah 3.
19 oh 2.4.
2.4.
Ya, 24.
So 2.4 itu yang 10V. Then you can get Q.
Ya.
But that Q ialah Q mana?
Total
Then you can take Q itu Q mana?
total ketiga tu ya.
Itu
Q
kan total
bagi
ketiga-tiga.
4 dan 6
Q kedua-dua.
2.
Ya, dua
Empat dan satu dan lima.
Kedua-dua. Which is how you get the 24 here.
Oh.
And once you get the 24, then you can get the V1. And then you can get the V2.
Ini kan
Nah,
juga ini.
do it step by step. Pelan-pelan.
Mesti.
Nah, key point-nya kamu concentrate EV senang sikit.
Tapi soalnya
In fact, kalau kamu tidak mau, sebenarnya boleh because you already have 54. If you know 54 and you count this as 30, then this is minus 54 minus 30 get 24.
C.
If you know charge-nya di sini pula akan apa?
Capacitance bang.
Okay, but many ways lah, just can do and double check. So, sekali lagi kamu tengok yang paling penting dia punya apa? Dia punya perkaitan dia kan.
Ya.
So kalau dia mau total, gunalah formula. So
Okay, sir.
jadi yang paling penting apa? Kamu tengok dia apa? Parallel ke?
Atau series.
So kalau dia mau total 1 dengan 5
Sekarang kita ambil
parallel itu jadi 6 lah.
6 tambah
6 lah. So sini 6 dengan ini in series. So 1/4, 1/6 itu 1.
2.4.
Tambah lagi dengan 3.
5.4.
So 5.4 ialah jumlah
Capacitance.
microfarad. So Q equals to CV. So 54 microcoulomb. Okay. So lepas tu yang paling senang ialah siapa? 3 lah. 3 microfarad. Sebab Q nya sama dengan C nya, which is 3 micro darab dengan 10. Sebab dia parallel dengan itu. Okay. Manakala untuk AB, kalau kamu mau guna 54 minus 24 boleh. 54 minus 30 kan? 54 minus 30 lah kan? Sebab jumlah 54, sini 30, so sini atas 24 lah kan, sebab dia parallel lah. Okay. Ataupun kamu cari dia punya C lah, which is 1/4 plus 1/6, which is 2.4 kan, microfarad. So dia punya Q, but apa maksudnya QAB? Kan, AB dia ada.
Parallel dengan
Tetapi kalau dia series, kalau 24 maksudnya ini pun 24,
itu pun 20.
ini pun 24. And once you get the charge, kamu ada C nya kan, so kamu dapatlah sini 6 volt. Kalau sini 6 volt, kamu tahulah sini 4 volt. Dapat dengan 10. Sini 4 volt, sini 4 volt, sini pun 4 volt. Kan? So it's always come back to in series dan juga parallel. Okay, kemudian it also depends kamu bila ada kapasitor, sudah ada charge, kemudian kamu join dia punya charge. So for example, kita chargekan dia dulu kepada 10 volt tetapi in series 6 microfarad, 4 microfarad. Lepas tu kamu sambungkan dia AB 3 sorry 3 sambungkan begini. So AB ada charge, CD ada charge kan? Lepas tu kamu sambung begini. So charge will flow
Out.
until
Equal.
apa ikut?
Equal.
Q, C,
Q.
V,
V.
V is the same. Tetapi mungkin akan ada yang cancel. Positif akan cancel, negatif masih ada. Tetapi charge is conserved. So final total charge equals to final total charge. So be total final charge atau final total charge sama lah. Final total charge sama dengan initial total charge. Dengan mengambil kira kalau ada sudah yang sudah cancel. So contoh begini. Bila dia charge begini, initial total Q.
Final total Q equals to initial total Q.
Yes. So kalau begini, first kita mau tahu dia punya charge. So kalau in series dia 10 volt, kita tak tahu voltnya kan. So ini kena guna formula lah. Kan? So 1 over C, 1 over 6 micro, 1 over 3 micro. So C equals to 2 microfarad. So Q equals to 2 microfarad times 10 volt. So you get 20 microcoulomb. Then you join it like that. Maksudnya di atas ada 20 coulomb, di bawah ada 20 coulomb. Tetapi kamu perlu tahu di mana positif negatif. Positif ke negatif pak?
Apa sih?
Positif,
Positif, negatif.
positif, negatif, positif, negatif. So kalau kita join positif dengan positif, negatif dengan negatif. Okay, so maksudnya selepas di charge di atas ada 20 microcoulomb, di bawah ada 20 microcoulomb. Lepas tu kamu join begini. Apa akan terjadi? Charge you flow until V is the same, until dia ada certain V. And then dalam case ini positif, kamu sambung dengan positif. So tiada yang cancel lah. Kan? Okay. So we need to find Q1 prime and Q2 prime. Final charge-nya. Initialnya 20 plus 20 microcoulomb plus 20 microcoulomb. Now how to we solve? Ada dua unknown. What else do we know? Pada final
V.
V is the same. So macam mana kita mau guna? Q1
Guna proportional.
Q1 proportional
Enggak.
susah sikit sebab dia sudah ada kesamaan serentak kan. But Q1 boleh juga if you want to make another equation. V equals to V kan. What is V? V1 equals to V2. C equals to Q per V. V equals to Q per C. So Q1 per C1 prime kan. Oh, we just do something like that. Q equals to CV kan.
Yeah.
So C1 C1 V, C2 V. So boleh dapat V. Right? 40 micro. So V equals to 40 micro divided by 9 micro. Kan C1 plus C2 kan. So 40 per 9. Okay, so the rest is just maths. So Q1 prime equals to C1 which is 6 micro, multiply V, which is 40.9. Q prime 3 micro, 40/9, so 13.3 microcoulomb and 6.7 microcoulomb. Yang ini pula dia mula dengan parallel. Lepas tu dia susun begitu, A B C D. A B
C D.
D. Di mana? Okay, sekejap. So first thing, cari charge-nya lah kan. Saya find the original charge. So C equals to C1 plus C2 lah kan. Dapat dia parallel kan. Boleh juga begitu, but in this case jangan lah. Lagipun kita bukan mau total charge pun. Kita mau charge on each capacitor. So just C1 C2 lah. Q1 Q2 lah. Much faster, and that's exactly what we want. 6 micro times 10, so 60 microcoulomb and 30 microcoulomb. Hanya how are we joining it? Positive, positive, negative, negative, positive, negative, positive, negative. No? Kalau ini susah tengok, you can actually rearrange back to like this. Masalah sini positif, sini negatif, sini negatif, sini positif. Right? Dan here kita memula dengan 60, 60, 30, 30. So is the charge still 90? Adakah dia masih 90 jumlahnya? Because this is positive 60. Kamu join dengan negative 30. Kalau kamu join dengan dia positif negatif, okay. It's the same as just now. Tetapi sekarang begini. So dia akan cancel. In fact, the total Q will actually be 60 minus 30. Kan? Sebab kamu join positif negatif. Half of it discharge sudah. But the final Q1 prime plus Q2 prime akan jadi begini. Okay, the rest is the same like just now. Kenapa dia mau begini? Actually, if you think about it, kan? Kenapa dia mau join positive negative? What will happen if you join back positive with the positive? $60, 30. You know what will happen? Nothing will happen. Because it's exactly the same as you take this one. Kan? Sebab dia 10 volt, 10 volt. Kamu sudah, dia tak akan bergerak apa-apa. Sesuai soalan dia tak akan tanya begitu. That's why dia terbalikkan ini negatif, ini positif. So charge akan. Okay, so just complete it. You get Q1 prime 20 microcoulomb and Q2 prime 10 microcoulomb. That's why yang ini susah nampak. Where's the V? Kan? Dia tu kamu tukar balik begini, dia begini. Kan? Dia akan mengalir sehingga V-nya atas sama dengan bawah. Okay? Which is why you get the C1V, C2V. So you can take out the V, you can find the V, then you can find the Q1N, Q1 prime and Q2 prime.
Kalau ini bukan sama kan Q?
Apa yang sama? Q not the same. Dia akan mengalir. Dia begini. Dia bukan sama. Sebab yang ini dia kamu sudah charge baru kamu ambil dua ini baru kamu susun begini. Yang dia sama kalau dua-duanya uncharged and then kamu charge dengan satu bateri. Kita understand that. Dia sudah charge baru dia susun kapasitor begitu. Dia bukan susun baru dia charge. Energy stored in capacitor U. Ada 3 form. Seperti juga kamu punya spring. You remember spring? Spring punya U? 1/2 Fx or 1/2 Kx square. 1/2 QV. Does it make sense? Sebab Q charge, V is work per charge. Tapi kita tak tahu kenapa ada setengah di situ. You see later. Okay, kalau tak mau Q, kalau tak mau Q,
Kalau kita mau
Q tukar pada CV.
CV.
So dia akan jadi half CV square.
Ayo sama.
square.
And kalau tak mau C, tak mau V.
V tukar C, Q per C.
Okay, so half Q per C square. Q square per C.
So yang first tu 1/2
QV.
Dia ada square.
Ya dah. QV itu yang senang sikit kamu ingat, because Q, V is itself work done per charge kan. So times Q lah, dapatlah work done, dapatlah U. But kenapa ada setengah? It's the same reason macam yang kamu punya spring. Half of the energy is lost somewhere. Okay, so V, what is V? Work done
Per charge.
per unit charge. Very good. Tetapi because it's not constant, so we need to integrate lah. So we do like this first, dW equals to V dQ. And then we're going to integrate it, so we get W. Okay, dW V dQ. So U, which is W, is integrate from where to where? U, which is W, so integrate V dQ from, kerja yang digunakan untuk mengecasnya daripada awalnya. Awalnya berapa casnya? Q. Initially the charge is
Q.
0 to Q. 0 to Q. But how do we integrate V? We cannot integrate V dQ. So V we change it to
C.
C per Q.
Q
per C.
Q per C.
Q per C. Okay. 0 Q. Q per C dQ. Tolong lagi integrate lah. Just change it to Q per C. Q dQ. Integrate Q dQ.
Q dQ.
Integrate X dx.
Satu per
1 per 2, X square per 2. Right. So Q square per 2C from 0 to Q. So kan di atas you get Q square per C. So half Q square per C minus 0 kan, tak apalah, itu je lah. So either this form or QV or CV square. It depends, kamu kena berhati-hati which one you need to use depending on what you know for that situation. Okay, tapi kenapa half di situ? If we're charging it with a E to a Q and a negative Q, charge stored is a Q. Energy supplied to transfer Q equals to, by definition, apakah maksud E? E is E as in same with V ya, hanya kita guna symbol E saja. EMF kan, istilah word energy supplied kan, supplied to Q. E is energy supplied per unit charge. So charge nya sekarang adalah Q. So Q, E lah,
QE.
QE kan, it's just like QV kan, Q times V. Just like Sebelumnya kita guna apa? W equals to QV kan?
Ya.
Right? Tetapi energy stored hanya setengah QE. Setengah QV kan, tapi dia akan charge sampai sama dengan E kan? V sama E lah kan? So kamu supply QE, tapi energy stored-nya baru half QE.
Energy loss.
Half
Half QE.
QE. Macam kamu punya spring juga kan, it becomes half Fx and not Fx. Okay, nah yang ini pula we look back in terms of energy, insertion or removal of dielectric. If capacitor is charged and then disconnected, and then bukan dua, and then dielectric inserted, does the U increase or decrease? Dia sudah charge, lepas tu kamu disconnect dia, lepas tu kamu letak. Macam increase, macam decrease. In this case, jangan terus cuba assume. It's actually not easy because you need to know first formula mana kita mau guna. Formula mana kita mau guna depends on apa yang constant. So you look at Q, V and C first. What happened to Q, C and V first? In this case, in this situation, yang kita pasti mana? Q, C ke V? Q constant because it is disconnected. Very good. V, do we know? Not so sure. Tapi C increase. Increase. Sebab dielectric. So gunalah formula yang ada Q dengan C. Dan jangan guna formula yang ada T. Right? So use half Q square over C. Right? So Q constant, C increase,
U decrease.
so U decrease. Right? Kalau mau juga guna CV, contohnya CV square, boleh.
Tapi kan
But first you determine first what happened to your V by
C.
C equals to Q per V. Q constant, C increase, V decrease. Kan? So V decrease. Tapi susah juga.
U lagi nak.
Or you use half. Sorry. Susah sebab C increase, V decrease kan? Susah. Unless you use half QV lah. QV okay lah, Q constant V. Okay? But this is easy lah kan yang ini kan? Okay, wait. Why do you think the U will actually decrease? If U decrease, macam juga sebelum ini, work done by the field or on the field? The easiest always
On.
look back at gravity.
On.
On kan?
ya
On kah? Bukan by kah?
Decrease kan?
Kalau U decrease untuk gravity, dia jatuh kan?
Counter gravity.
U nya, bukan K nya. U nya decrease kan bila dia jatuh. So dia jatuh sebab field nya. So work done by electric field. So bring dielectric in. In fact, if you think about it, because it's positive, negative, gini kan? Kamu letak tu dielectric di sini, dia sudah polarized sudah, kan? Negative, positive. In fact, there will be a attraction. So dia sebenarnya dia akan pull dia ke dalam. Dia akan tarik dia ke dalam. So bila dia tarik ke dalam, of course U-nya decrease. So, because the work you can buy the fuel. Okay, on the other hand, kalau kita sudah charge, disconnected, and then barulah kita tarik dia keluar. So kita charge dengan insulator, lepas tu dia tarik dia keluar. What will happen to the U? And then try to justify it, kenapa U ni boleh meningkat. Okay, bukan agak-agak you see, is there a reason for it to be constant? There is a reason for Q to be constant because it is disconnected. Unless it is still connected to the same battery, then V will be constant, and then Q will increase. Sebab dia akan keep on charging ataupun lose some charge. So C will decrease. So you can just use half Q square per C. Okay. If you cannot remember, you want to use QV, then you have to CV lah. So in this case, U will actually increase. Work is done on the electric field to pull the electric up. In fact, dia sebenarnya ada daya tarikan. Nah, dia ada daya tarikan antara dielectric dengan itu. So kalau kamu pull, kamu kena gunakan daya. So energy dia increase. Same like spring.
Energy
Kepada bukan kita kan.
Same like spring. Kita mau pull dia kan, semakin jauh kan.
So U tu energi yang elektrik tekan, bukan kita.
Of course the electric, bukan kita. Energy stored in the capacitor.
Kalau kita U kita turun kan.
You turun lah because you use chemical energy to move your muscle.
Kita guna tenaga.
Itulah cepat lapar. Okay, this one we already have the capacitor, already have a charge. Okay, macam mana dia charge itu sudah berlaku. So you just connect it positive to positive, negative to negative. Find total loss of energy. Okay, try it. It is 3.24, 10 power negative 3 joule. Okay, you see what should be applied. Ya kan? First we find Q1 prime and Q2 prime. 280 microcoulomb, 150. Okay, next part is actually easy, but just jangan tak ambil benda yang salah. Right? Sebab initial kita ada C dengan Q saja, kita tiada V. Yang kamu cari V itu ialah V final, so jangan guna itu. Instead use Q square per C dan jumlahkan untuk initial. Final boleh guna yang V. Okay, ini baru kamu tolak. Initial kamu ada Q and C masing-masing, kan? So initial, total initial energy, you use half Q square per C plus half Q2 square per C. In this case micro penting itu untuk kamu kira, because it's a square kan? Kan? Kalau formula lain CV pun perlu, QV pun perlu, CV square pun perlu. In this case mesti micro because your answer is going to be in joule. Micro.
So, 2 exponent negative
Final?
8 kah?
Sekejap. Final?
Q dengan V.
You can use
QV.
You can use QV because you have the V and the Q. You can
Q
total
prime.
the Q. Okay. If you don't want, then QV lah boleh juga. Q1, Q2 prime. V nya sama kan? V which was your final V.
Yang itu pasal saya.
If you use C, actually boleh juga. You can use C juga, Q1 square per C boleh juga. You can use this one. Tapi guna Q1 prime dan Q2 prime lah. C1, C2 tak berubah kan? Okay, next kita mau tengok dia perubahan mengikut masa time. So discharging dulu, dia ada charging dengan discharging. Discharging formulanya lebih senang. So we start with discharging, where we have a capacitor yang sudah ada charge, then we discharge it through a high resistance. Maksudnya dia sudah ada charge dan kita sambung dia dengan satu resistor yang tinggi. Why do we need high resistance? Sebab kalau kamu guna wire biasa saja, low resistance, sekejap saja, zup, saja sudah charge nya. Ya, itulah dia guna high resistance lah, R, supaya dia akan flow. Okay, so Q nya akan berkurang, kan? When you connect it, the charge will flow like this. So Q-nya akan berkurang. So you need to take note Q initialnya Q0 on this side, and negative side will be negative Q0. Tapi charge it says Q0 kan. So charge will flow. Flow of charge is I. And across potential difference of V. So we're going to combine it with V equals to IR to find our formula. Okay. At any instant, V is equals to V across the C is also equals to V across the R. Okay. Actually dia punya pembuktian panjang saja. Kalau kamu guna hafal, you just need to know, you just need to remember and determine whether dia meningkat atau menurun. Sebab meningkat satu patternnya, menurun satu patternnya formula. Okay, let's first look at C. C equals to Q over V. As time passes by, apa akan berubah? Bila dia sedang mula Q menurun, so V menurun. How does this affect the I? Then we say V equals to IR.
I meningkat.
So when V decreases,
I decreases.
I pun decreases. That's all. Which means that we know as time passes, Q decreases, V decreases, I decreases. From macam Q itu daripada maksimumnya Q0 kan. So from maximum to 0. So lepas dia habis, dia sudah charge kan, ngam lah. So same with V and same with I. Okay. How about R and C? Does it change?
Yes.
Constant.
Yeah, constant.
Because it depends on the capacitor and the resistor that we use. Okay, so we want a formula. Where do we want to start? Where should we start? Let's look back at initial first. C equals to Q
Over V.
initial, which is Q0, over V initial, which is V0. How about V equals to IR?
V not.
V0,
I not.
I0. Very good. How? Yang formula mana ada T? Which one has a relationship with T? T.
T time.
Time. Yeah, we need time. Yang mana ada time? C, Q, V,
Q.
Q, T. Apa tu? QT.
I T.
Yes, I lah.
I.
I yang ada T.
Yeah.
Kan? Okay. So we actually going to start with I. But a little bit different. We're going to define I equals to negative dq dt. Why do we need a negative? Because I normally we don't call it negative kan. I is positive kan. But now the problem now is dq dt is negative. Your dq dt in this case is negative because Q is decreasing. And Q menurun, dq dt negative. But I is positive, that's why you need to put a negative there.
Positive.
Okay, so now we get our T. Yay. Okay, but we need to integrate with Q, dq. Yeah, we cannot integrate I dq because I itself is changing. So tukar mana rasa-rasanya?
I V or I.
Or should we say I? Macam mana kita tengok?
Yeah. We are.
Or should I say di antara dua formula ini yang mana ada di kedua-duanya?
V.
V. So we try to change everything to V. Okay, if not we cannot relate everything. Okay, so I we're going to change it to V for R, right? Q we're going to change it to
CV.
CV. Very good. So we're going to rearrange it. Sekejap. When we do D, CV and C is a constant, then we can put it up, keluarkan. So in the left with a dV dt, negative C, dV dt, V and R. Step ini baru kamu belajar, but it makes sense lah. dV, V, kumpul lah di satu belah, kan? V dengan V. dt, tiada T, so never mind lah, just put it here, dt. Sini, dV. Sini, V. 1 per V. Right? Apa lagi?
R2
R and a C doesn't matter because it's a constant.
Negative.
So you can just put it anywhere you like. Okay? But it's better to put it this side. RC. Okay? RC or 1 over RC?
Bukan R.
R per
1 over RC.
1 of R is
1 over RC, yeah? Okay, 1 over RC.
Oh. Oh.
Anything else?
negative.
Negative, want to put it where?
Sebelah.
Di dt lah, senang sikit. Then integrate.
From
Ini pun integrate. Sebenarnya dia integrate begini, kan? But because RC is a constant, we just integrate dt. Okay. You're gonna learn this in your maths. Susun, lepas tu kita integrate. But since we don't want to do the plus C, kita tahu juga apa ini. So just put it in lah. Okay, like time. We are integrating from 0 to time t. Whereas the V is from 0 kan? No, you have to be careful. That's why you need to know what is the happening at the initial. Initially V is not 0. Initially V is V naught. V naught to V. Okay. Tak susah juga kan? Like they ask you to prove, banyak makalah, just don't get stuck lah. I think the idea just now was apa kan V kan? V. Why do you want to put the V? Kenapa kita tak mau buat DQ?
Tapi itu ada boleh kita kait.
Siapa yang betul? Okay. Integrate dt maksudnya integrate dx. Maksudnya integrate 1 dx walaupun kita tak letak 1 di situ. If you want to put back 1 lah.
1
Integrate 1 bukan, integrate 1 dx equals to
X
x. So integrate
T
t. So negative c t from 0 to t, which is a t. Which is a t minus 0, so it's a t. Ingat ke x kan? Mana ada x?
Terus.
Terus, oh jangan. You need to, sebab tidak semestinya kosong ke t. No, like v bukan kosong ke v. How about 1 over v dv? 1 over x dx,
X
Negative.
square.
No, 1
Tidak.
over X square.
which is x negative 1.
Satu per X
So,
Negative 1
kuasanya
over
negative.
X square.
Negative 1 plus
1
negative
over.
plus 1 kan?
yeah,
Plus 1 jadi 0.
0.
Ini
So
tambah
is-
rupanya seperti.
No, it doesn't work. It doesn't work and you learn it later. Now you just need to know integrate 1 over x dx is actually ln x. Ln.
Lon V.
Yes, so it's going to be ln v from v naught to v. I thought we did this in bila?
Fizik 2.
No, no physics.
Maths.
Chemis.
Yeah.
Ya, chemist yang
Chemist.
ada 3 graf tu.
Aduh.
Ada.
Ada.
So ini t minus 0, so just t lah. So negative t per RC ln v minus ln v naught. But you know ln minus 1
What?
divide kan?
Yeah. Yeah.
Ada tempat lagi ya? Next.
Divide.
Divide.
1 over 1. 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 1 over 1
Next page. Oh, tak ada tempat.
Di atasnya sir.
Alright.
Kami buat simple lah.
Okay. Problem. Negative P per RC. Ln V per V naught. So V per V naught equals to
B per B naught equals to
Equals
okay,
to
sudah kan?
E.
E power ini kan? Okay.
E.
So E to the power of negative P per
E
RC.
of RC.
So V equals to V naught E negative P per RC. Simple.
simple sejahtera.
Yeah. No, if they don't ask you to prove, you just need to remember this part. That's all. E negative exponent is a graph. What does the graph look like?
Gini.
Begitu.
Menurun kan? Tapi dia negatif.
Baik.
Negatif.
Negatif dekat X.
Dia bukan equal to T.
Iya,
Itu
begini.
biasa.
Menurun.
Hey,
In fact, for a graph of V, you start at the V naught and then you just exponentially go down to a zero.
kan gitu.
E negative X lah, kan? E equals to negative X. Okay, how about the other two? How about I dengan Q?
Kalau Q
From V ataupun from V lebih senang kita dapatkan apa?
senang kita dapatkan
I lah, I kan? Okay. So V, you change it to IR. V naught, we change it to
I are not.
I naught R.
I not are.
I naught R.
I not R. I
So, kenapa lah I? So I follow the exact same pattern. I naught E negative T per RC.
Oh, same pattern as V.
Yeah, because it's just menurun juga kan? Because it depends on V. It's
So
proportional
dia
to
begitu
V.
juga.
How about Q? Q.
Q.
Q tengok dari mana?
Tadi tu.
Which formula bagus?
Q
V lah.
Q over
V lah kan?
Q I T.
Oh ya.
V lah.
V sir.
IT jangan sudah.
So,
Because
equals
jangan guna IT sudah.
C
C
Q B
Q per C.
C ambil
So Q per C equals to Q naught per C.
yes.
E negative T per RC. Potong-potong. Exactly the same pattern. Okay. So V equals to V naught E negative T per RC. Q equals to Q naught E negative T per RC. I equals to Q naught I naught E negative T per RC. So all of them decreasing from maximum to 0. The formula is the same. The graph is the same. Q naught against T, I naught against T. Okay, the time constant is something like your half-life.
Time
You have a
taken.
half-life. Half-life kan dia constant kan. As long as an exponential graph, negative exponential graph dia punya time half-life sebenarnya constant. Okay, but we don't use half-life. Instead, because cantik sudah RC di sini. RC di sini. So we're going to call that a time constant. Tau equals to RC. Tau.
Tahu.
Tahu.
macam mana
Asik.
bentuknya sih
Tau.
Dia macam T tidak bersambung.
T yang
T kaki
T. T.
Oh ini.
mana kak oh
Tahu.
tahu
Tahu. Saya tahu.
kau tahu
Oh, ya kan? Nilai itu.
tahu
Boleh.
Mana saya
Kenapa
tahu?
saya?
mana saya tahu
Okay. It's time taken for charge for Q in capacitor to drop to, because what will happen in RC? Kalau masa kamu RC, because it's E negative T per RC. So if your time is RC, then become a E negative 1. So time taken for Q in capacitor to drop to 1 over E of its initial value. Kalau half-life, drop to 1 over 2 of its initial value. Okay. In fact, you find the half-life will be something RC with a ln 2, I think. But since we just want to see the value, 1 over E. So time taken for Q to drop to 1 over E. But sometimes we don't actually measure Q. It's easier to measure I. Kan? So it's or V or I. So sama juga. Kan?
Oh, maksudnya antara 300 lah.
Antara 3. Which practically we measure V and I, we don't measure Q kan.
Yes.
So it's the same concept with half-life. Di mana selepas satu half-life dia akan jadi 1 over 2. Tapi ini selepas satu times constant dia jadi 1 over E. Selepas lagi satu times constant dia akan 1 over E 1 over E. So 1 over E square. So
Lepas 1 tahun lagi
1 tau lagi ni akan jadi 1 over E cube. Tetapi taunya constant.
Taunya
Just like half-life is constant. Tau. It's actually very easy to prove because when T equals to tau equals to RC, that is exactly what we get. Q equals to Q naught, E negative, RC per RC. So 1 over E, Q naught. Okay. One over E is around how much?
So apa di bawah tu AC?
RC per RC. Because it's T over RC kan, so when the time is RC, so then RC per RC.
Jadi 1 ke tu sah? Jadi
E
1.
negative 1, E negative 1, so 1 over E. Okay. In fact, it's not so much for calculation, but to describe. What's happening. Okay, and also in the terms of the graph, for example, Q time taken from Q naught to 1 over E. 1 over E is 2.7. 1 divided by 2.7 is less than half lah. Let's say around here lah. 1 over E Q naught. So if it takes this time to become to tau,
half lagi.
so when it becomes 2 tau, it's not half, it's
Half from
bukan
1
half
over-
juga, tapi masanya sama. 1 over E square.
Iya, dalam buku tu.
But time-nya sama,
Tahunnya sama.
tahunnya sama.
Yang 1 okay lah. Q-nya lagi.
It's used actually more to describe cepat ke lambat dia. Cepat ke lambat dia discharge sebenarnya. Okay. So apa yang mempengaruhi tau? A dengan C. So A increase or C increase, so tau will increase, which means that it will discharge faster ke slower? Careful.
Discharge.
Slower ke faster?
Apa yang
A tinggi atau C tinggi? It will discharge slower. And does it make sense?
Tangan.
Yes, because if you discharge it through a high resistance, currentnya kecil, so dia perlahan. Tapi kalau C tinggi, maksudnya dia banyak charge kan additionally.
Oh, bisa dengan bawa ke sana lagi.
Kalau AC kecil, cepatlah dia discharge. Okay, so whether it's a graph of Q or a I or a V, if we have probably tau 1, tau 2,
tahu tu, tapi kenapa sih dia bilang?
it makes a different graph lah. So if tau 2 bigger than tau 1, that means it takes longer to discharge. Nah, kalau C-nya kecil, sikit saja charge-nya, you use a low resistance, kejap saja dia discharge habis. But if you need to be slower, use a higher R and higher C. Ini pula charging. Sepatutnya charging baru discharging kan, but
Yes,
because
yes.
discharging is much easier.
Oh, okay.
So sekarang apa pula kaitan A dengan C dengan E? A dengan C is in sebenarnya tadi di parallel, manakala sekarang dia series. Very good. So if in series, what happened to the V?
Plus.
Tambah. Okay, very good. So at any instance, E equals to VR plus VC. So slightly different for Q. Okay dulu. Now your Q, you are charging it. So Q is increasing or decreasing?
Charging increasing.
Increase. Which means the punya bentuk akan lain daripada tadi. How about I? V? V as in the V, of course we are more interested in the V
Apa sih?
of the C and not the V of the R. Kan? Because we are interested in the V apa?
Decrease.
Increase juga.
Hah?
Because mulanya dia tiada charge.
Bukan kan CQ per V.
No, V. Pada mulanya dia tiada charge, so tiada V. Initially. So from 0 to maximum, ini logik lah. Discharging QV menurun, charging QV meningkat, discharging I menurun, charging macam. But now we are referring to I in the circuit. Bila kamu mula-mula charge, I-nya tinggi because dia masih kosong. Semakin lama, ya bila penuh sudah. So I is the one that is different. It is still decreasing from maximum to 0. So in fact, I will follow the same formula as just now. Tapi QV akan berlain.
Masa pada R kah?
Bukan, you have to understand the charging. Bila kita charge-nya, pada mulanya senang current masuk. Bila dia mula penuh sudah, I akan semakin sikit. Bila dia penuh sudah, tiada I.
Charge dekat kapasitor.
Ada charge lah, semua charge pada sini, tapi tiada sudah I sebab dia sudah penuh.
Dia
Jadi sudah boleh
Tiada
masuk.
sudah mengalir. Ya.
Oh.
Discharging pula lain. Discharging dia pula,
Dia increase.
dia decrease juga, tetapi sebab I itu mengalir dari dirinya sendiri. So bila dia habis charge, tiada I lah. Ya ini bila sudah penuh, I tak akan mengalir daripada E
sudah
sudah.
muat.
Ada
Sama sudah
muat.
V-nya kan.
Yes, very good. So
Sama
RCE constant.
Kalau ada dia punya beza keupayaan baru dia mengalir.
Which one? Kalau dia punya beza keupayaan across the capacitor is less than the beza keupayaan across your battery. Because charge will flow until potential difference is the same. Always.
Then EA.
Okay, so here we have to be a bit careful because there's 2V. There's 2V. Kan?
E sama.
So for VC is, how do we get VC? From C equals to Q over V, which means VC equals to Q over C. How about VR?
VR.
As in V for the R, bukan V darab R.
V tolak Q per C.
No, this one will be IR.
Ayo bisa.
Yeah, V equals IR. Okay. And then, yeah, of course, we say tolak, that means this one lah. This one is also important. VC plus VR.
R ke?
Okay, so we're going to use this 3. What we are still going to start with, yang mana ada T?
V.
Q.
I.
V
I saja.
Oh ya, I saja.
Okay, but a few other things you need to take care of. Initially, now there's so many things. Q or no? Q, you know. Initially Q. You know is 0.
Ya.
V is 0, but V is apa yang 0? VC ke VR?
V
VC is 0. sebab dia belum ada charge.
Oh,
Dah like.
So if VC equals to 0, VC plus VR equals to E, that means your VR equals to E. So dia akan jadi V equals to IR. V equals to IR, which means that E equals to I naught. I naught is the initial I. Finally,
Q.
VC is going to get the highest. VC akan jadi apa? Dia akan charge sampai dia sama dengan
E.
E.
Yang
Kan?
VR jadi kosong.
Yes, very good. VR equals to 0. I
I
0, no more I. How about Q not? Q.
Q.
Q-nya maksimum.
Maximum which is
Q na. No, Q.
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 CV.
CV. So C E.
E. E. Yeah.
You can think of this as Q naught, but Q naught because not normally initial kan. As in Q maximum lah, then this is a Q final which is a maximum. This is the V maximum which is a maximum. V. Okay, so I. You still need to start with I, but do we need the negative?
Coba ke Inggris enggak?
Tak perlu. Okay. But the problem is apa? I itu. Q equals to CV, so C dV dt ya. But the problem is the I. Because we are interested in the VC ke VR? VC kan? VC kan? But we cannot just take this as a IR. I equals to V per R. Because that will be VR and not VC. Kan? So how do we settle this? We use back receivers. E equals to
I not R.
VR plus VC.
C.
VC plus VR lah. VC plus VR because VC is the one that we want.
Okay.
So VC we are going to use V. Okay? And VR we are going to use
A.
IR. Okay? So what is I?
I.
DQ.
So
E
kasi
tolak
masuk
V
lah
bagi R.
DQ as
Yes, very good. E minus V bahagi
minus V bahagi R.
But it almost the same. You see the RC?
dV per dt. RC.
You see the RC? Right? So same thing. dt dV. 1 over RC, negative on this side. And on the other side,
dt
1 over
C
E minus V. Tak boleh kita pisahkan.
Oh yeah.
You have to take this thing and then you divide it. Tadi 1 over V dV kan? So this 1 over... ada negatif tak?
Ada.
Neo. Okay. Integrates.
Nggak ada negatif tu.
Di sini sudah kan saya pindah ke AC.
Let's see.
So this is going to be negative 1 for RC. Integrate T. Oh ya, from belum lagi. From kebalik lah kan ya. Sebab dia charging kan.
Tapi masih juga.
Masih lah.
Time masih sama. Tak tertipu. V nya?
V-nya yang
V nya yang
V
0 to V. VC ya, we are referring to VC kan. VC pada initially 0. Yang tadi to V not B. This is. So a bit different here is that this is like integrating 1 over 1 minus x. Okay, so it's going to be ln 1 minus x. But because there is a negative here,
Negatif lang.
yeah, then negative ln. Okay. So it's going to be negative ln E minus V from 0 to V. So you get negative E per RC. Okay, so you substitute to the V.
So, tolak negatif berarti
Yang ini substitute to T sebab dt kan, yang ini substitute to V. Okay, so ini T lah kosong-kosong lah kan. So ini V to V. So you get negative ln E minus V minus
negatif
negative kosong masuk ke sini.
ln
So you get a ln E. So this is going to be a positive.
balik.
So ln E minus ln itu. So bila ln minus
Bagi
so E di atas E minus V di bawah. Negative E per RC.
kita cari apa? E.
V. V in terms of T.
Kuasa I kuasa
So E per E minus V equals to E minus T per RC. And the rest is just algebra.
cari apa? V
Ya Allah, tiga kali. Tipe apa tuh? Tipe apa tuh? Tipe apa tuh?
Arti.
Even V.
Ya bukan.
It's the fastest way.
I. Arti. Arti.
Terus sekejap ada negatif kah? Lihat dengan dulu. Is there anything wrong with the negative?
RC suara negatif
Awal-awal saya, awal-awal
Tidak ada.
suara negatif masuk.
Sorry, tidak kan?
negatif.
Tapi akhirnya ada negatif. So what should we do?
Oh,
Ataupun what's the fastest way to get the V out? Pecahan begini tak boleh buat apa-apa kan? Kita balikkan dia
ya 1/1.
1 per. So ini pun 1 per. So E negatif T per R. Right?
Ayo.
Terbalikan. Ah, dia megang di sini. Satu per bang. So ini 1 per juga kan? So negatif lah. Okay lah, so at least get 1 minus V per E. E negatif T per so
1
V per E 1 minus E negatif T per RC. So V equals to E bracket 1 minus E negatif T per selesai. Graphnya,
Macam tadi, sir.
but dia ada negatif and dia ada 1 minus.
Iya, begini, sir.
So this is V ataupun VC. Ini semakin kecil kan? So satu tolak semakin kecil. So it's going to you get nearer and nearer to 1.
1
Which means you get nearer and nearer to E.
No.
Which means E is asymptote. Actually like this. T. So that is for V. After we get the V, we should do for what?
I
I macam complicated. Q.
Q.
Apa Q? Q macam tadi, it's just Q per C kan. V is Q per C. And E
Tadi
E is Q naught per C, but Q naught here referring to bukan initial lah, tetapi
Das
Q maximum
X.
kan. So Q naught per C, so the rest is the same. 1 minus E negative T per, so potong-potong. So Q follow the same pattern. Sebab Q also increasing. Q increasing, V increasing. So it has the same pattern. Q increasing, V increasing. In fact, if you put V naught pun boleh. It's easy to remember it as V naught. Tetapi V naught, you remember it, dia sebenarnya E. Kan? And Q naught is actually
X.
CE. But easy to remember V naught, Q naught lah. But it's not initial lah, it's actually maximum. How about the I? Guna mana bagus lah? I think this one lah. Kan? Because you already have V.
E tolak
E tolak BC. E tolak B kan?
tolak
E tolak B. Which means that you have E minus the V, which is E minus V equals to I. So E minus a V, which is E 1 minus E negative T per RC equals to I R. So macam potong-potong ini kan?
Ay tolak sama boleh potong
Tolak I kan, tapi tambah I kan?
atau dia ada lagi efek lagi
Sekejap.
Ya Allah.
Sekejap. How do we get the I naught? Ui.
Oh, oi.
Yalah tinggal E negative T per RC. Tinggal I kan? Is a E. It is a E. How about the R? You put it here. E over R is actually your I naught. So it's actually get by your I. Okay. Dan so I yang lain sikit because it is increasing. So it has exactly the same formula as discharging.
kenapa E tolak E jadi
Keluarkan E jadi satu.
E tolak I tambah II kan.
Kita tolak satu je kan.
Ini dua potong kan, tapi tinggal plus II kan. Okay. So bermaksudnya if you don't need to prove, you just need to remember this. If increasing, 1 minus E negative T per RC. If decreasing, E negative T per RC. Right? Untuk kesemuanya kan? And you can know it's increasing or decreasing sudah without you needing to do all the formula kan?
Mana increasing tu?
Increasing 1 minus E negative T per RC. Maksudnya if you know the situation is increasing, so bila discharging, tiga-tiga decreasing. So semuanya menggunakan formula ini. But when we are charging, the Q and the V increase, so you use this one. Tetapi I yang decrease, so you use this one.
hanya di
Hanya dia punya maximum a little bit different lah. Even though you can use Q naught, V naught lah, tapi jangan tekan V. So Q increasing or decreasing? Increasing to a maximum Q naught, which is actually equals to CE.
CE itu sama dengan CV kan sir?
But the E as in the, because you cannot use V pula merujuk kepada V ini, referring to the battery punya E, punya V. Okay, I sama lah kan, 0 to maximum kan.
Ay, bukan
No,
increase kah?
decreasing.
Okay, I got to.
Okay, gitu.
They can ask you to draw VR. VR.
Melawan
Guna air sir.
Yeah.
So means sama saja dengan air.
Air sir.
Yes, very good.
Yeah. Okay.
Dia juga ada time constant, which is the same thing, but it is also RC. Okay, but after time RC, dia bukan menjadi 1/E, dia menjadi sini. Tahu lah. Apa tu? You look at the formula. What happen when it become RC?
Jadi negative 1.
So 1 minus 1 over E, right?
Yeah.
And become 1 over E.
Bukan sudah.
C kah sir, bukan E kah?
Q. E. E is a E is a E is a E. So time taken for Q ataupun V. Bukan I ya, because I decrease ya. To increase from 0 to 1 minus 1 over E of its, dia akan jadi 1 minus 1 over E multiply dengan Q0, kan? Q0 which is the final value ke initial value?
Final.
Okay, of its final value. Okay, because you see final value nya di sini Q0 after a time of equals to time constant, dia akan jadi 1 minus 1 over E Q0. So it starts from a 0 to a 1 minus 1 over E to Q0. Selepas itu
1 minus 1 over E kurungan
square. No.
Square, E square.
E juga. Kenapa bukan?
But lain. Because the formula is di mana T per AC nya pada E nya.
E.
So E negative 2.
Ay, ya.
Dan bukan kurungan negative 2. Correct? So unless they ask you to prove, you need to know everything lah. If not, you know the form, then you can answer the question. Okay, yang ini. So we have a capacitor. We have a resistor 10 to the power of 6 ohm.
Resistant.
So it has to be a very high.
Oh.
Okay, yang ini jawapannya 2.08 second and 6.91 second. Yang di bawah 1 per E Q0 Q. Yang di bawah sini 4.0 milli ampere. Ampere. Okay, one by one terus. Yan, half 50% charge. Maksudnya you want the time when your Q equals to half Q0. But what formula should we use? Charging, discharging. Charging Q meningkat.
Distance.
Charging. Charging. So the formula is Q0
Q0
1 minus
1 minus
E
E
negative T per RC.
per RC.
1
Because it's charging. Charging Q increase and use this formula.
Q tu yang akhir kah?
Q akhir, in fact you can find the Q naught, but in fact it's not needed.
Charger pun pula dia
Because
charge.
when you put this into here, you actually cut away your Q naught.
Bukan charger, bukan discharge.
Charger pula.
Charge.
Ya dah baru tahu.
Okay, so dia ini farad kan?
Farad.
Farad. Dan dia masalahnya ambil Q sebagai Q naught. Okay, so adjust lah sedikit. Q prime lah sama dengan Q. E negatif. E per AC. Finalnya I bukan kosong kan? Tapi dia find current when switch is closed. Sebenarnya dia mau I naught.
I kan.
Sebenarnya itu je.
Dia anu kan sir.
I naught.
Charge.
Charge.
Uncharged tu.
Mula-mula dia uncharge, lepas tu dia charge.
Uncharged maksudnya.
Ya, maksudnya bila dia close itu kapasitornya masih uncharged.
Masih kosong.
So it's actually just
Charge.
E per A. That's all.
E per A.
I naught bah. Sebenarnya dia mau cari I naught. Kan? I naught. So E per A. That's all. Ini tiada guna because when your switch is closed, the charge is still 0.
Oh ya.
Pemilik ini.
That's actually itu the one is just V equals to IR. That's all.
Zero sir.
Huh? C0 bukan?
F.
Apa tu?
Farad kan.
Apa tu? Initially
Oh
uncharged.
iya.
Okay.
Sir,